In this lesson, we are going to briefly talk about correlation versus causation. So when we look here, does the television extend life? This is not on your notes, so just take a look here. Measure the number of television sets per person and the life expectancy for the world's nations. There is a high positive correlation, meaning nations with many TV sets have higher life expectancies. The basic meaning of causation is that by changing X, we can bring about change in Y. Could we lengthen the lives of people in Botswana by shipping them TV sets? So think about that. If I was going to give people TV sets, does that mean they're going to live longer, since there's a positive correlation between your number of television sets? Hopefully, you would say no, right? Rich nations have more TV sets than poor nations. They also have longer life expectancies because they offer better nutrition, clean water, better health care. There's no cause and effect tie between TV sets and the length of life. So hopefully you would pick up on the fact that, well, if you have TV sets in your nation, you probably have other things that are a luxury, and so you would have better health care, you would have more clean water, things they listed there, which is why your life expectancy is longer. It's not because people have TV sets, and hopefully that makes sense to you. So now when we look at the next one here, it says strong correlation does not mean that the change in one variable causes the change in the number. For example, our TV problem here. Determining causation is done by randomized experiments. So we can't say something causes something else unless we do a big experiment with it. And it's actually quite a bit of a process to make that happen. So you'd never say something causes something else without doing a random experiment. The types of causation you could have. One is direct causation. The change in X causes a change in Y, and there's no lurking variables. My foot size determines my shoe size. There's not a lot of other things that impact my shoe size. There's not a lot of things you could think of right now, like what else would make your shoe size bigger? Well, maybe if you have a big bunion. That's not something we're thinking of because that's not most people. Maybe you don't cut your toenails. Well, that's not really going to happen. So there's very, very few or no lurking variables in direct causation. So this is an example of that. The other types is a common response. Both the cause and the effect change as a result of the lurking variable. So for example, SAT scores and college grades. What can affect those? Both. Like what could affect both your college grades and your SAT scores? What kind of things affect that? So what other things would cause your SAT scores to go up and your college grades? So some things that might be lurking variables there would be how much time you study, maybe, study time, how much sleep you get. Another thing would be for college, especially how many classes you attend, so your attendance. What else? Your natural ability, maybe, your IQ. So here's some examples of some lurking variables that can impact your SAT scores as well as your college grades. And then this last one is confounding. Both the cause and the lurking variable cause a change in the effect. So your college grades determine how much money you get in your first real job, which could be true, right? You get hired, better grades you have, maybe you're going to have more employment opportunities. What else affects how much money you make in your first real job? Well, one thing would be who you know, like your family connections maybe. Your dad owns the business, you might get a job over someone who has lower grades. Another thing would be where you live, or how much experience you have in that field. Maybe even your personality, you know, not just your grades, but how you relate to people. Are you a people person? Are you very introverted, extroverted? That might determine how much money you make. I'm sure you guys can think of lots of things that would cause that. So, if you can't do an experiment, how do you establish causation? The way to do it without having an experiment to establish causation is you need to have an association that's strong and consistent. Higher doses result in stronger responses, meaning bigger samples. Cause precedes effect, so it comes before. If you don't know the word precedes, comes before. And the alleged cause is reasonable. So those are all things when you're not doing an experiment and you want to try to establish causation that you're going to look for. You'll see you have some examples like that in your worksheet tomorrow, so hopefully that'll help you.